Forged, how jet engines are actually manufactured. Every commercial jet engine starts as raw metal, nickel, titanium, and specialized alloys, and ends as one of the most precisely engineered machines humans build. This is what happens in between. It starts with the turbine blades, the most demanding manufacturing process in the entire engine. These blades sit directly in the hottest section of the engine, exposed to gas temperatures exceeding the melting point of the metal itself. A normal cast metal part is made of millions of tiny metal grains randomly oriented, and the boundaries between those grains are where cracks start under extreme heat and stress. Turbine blades cannot have that weakness. The solution is single crystal casting. A ceramic mold shaped exactly like the blade is filled with molten nickel, superalloy inside a vacuum furnace. Then, instead of letting it cool naturally, the mold is drawn slowly out of the furnace's hot zone at a precisely controlled rate, sometimes just a few millimeters per hour. This forces the metal to solidify as a single continuous crystal structure, growing from one end of the blade to the other, with no grain boundaries anywhere. One imperfection in that cooling rate and the crystal structure breaks. The blade gets scrapped. Once cast, each blade gets internal cooling channels, intricate passages drilled and cast into the interior that will eventually pump cooler air through the blade during operation, protecting it from gas that is hotter than the metal can survive unprotected. These channels are so precise they're often formed using a ceramic core that gets chemically dissolved out after casting, leaving behind passages smaller than a coffee stirrer, positioned to within fractions of a millimeter of design tolerance. The fan blades, the large blades you see when you look into the front of the engine, are made completely differently on modern high-bypass engines. Rather than metal, they're built from layers of carbon fiber composite material, laid up by precision robots in exact patterns, then cured under heat and pressure in massive autoclaves. Each blade is a complex 3D curved shape that would be nearly impossible to produce from solid metal at this scale and weight. The engine's core casing and structural components are machined from titanium and nickel alloy forgings, starting as blocks of metal weighing hundreds of pounds, then cut down on 5-axis CNC machines that carve away over 90% of the original material to reach the final precise shape. The machining tolerances on critical components are measured in microns, thousandths of a millimeter. A deviation smaller than a human hair can fail an inspection and send a $100,000 part to the scrap bin. Every single fan blade, turbine blade, and rotating component gets individually weighed and balanced before assembly. An imbalance of even a few grams on a component spinning at 10,000 RPM creates vibration forces that can destroy an engine over time. Components are matched into balanced sets. Blades of nearly identical weight are grouped together and mounted at specific positions around the disc to cancel out any residual imbalance. Final assembly happens in clean rooms with strict contamination control. A single piece of foreign debris left inside a completed engine can cause catastrophic failure. Technicians follow strict protocols. Tool control systems track every wrench and fastener used, and nothing leaves the assembly area unaccounted for. The engine is assembled in stages, each one inspected and signed off before the next begins. Before an engine ever gets bolted to an aircraft, it goes through extensive ground testing, running at full power for hundreds of cycles, deliberately ingesting water, ice, and even dead birds in controlled tests to certify it can survive real-world conditions. Engines are run to intentional failure points during development testing, specifically to find out where the limits actually are before they're ever discovered in service. From a block of raw titanium to a certified flight engine takes months of manufacturing, thousands of individually machined and inspected components, and tolerances tighter than almost any other manufactured product on Earth. Every engine that leaves the factory represents thousands of hours of precision work that most passengers will never think about as they board. Follow Forged, how things are really made. Link in bio.